Dark matter, the invisible mystery of the universe. The universe is vast and filled with mysteries, but one of the most perplexing is dark matter, a strange and invisible substance that makes up 85% of the total matter in the cosmos. Despite being the dominant form of matter in the universe, dark matter does not emit, absorb, or reflect light, making it completely undetectable by traditional telescopes. Yet, even though we can't see it, we know it's there. Its presence is felt through its gravitational pull, shaping galaxies, bending light from distant stars, and playing a critical role in the evolution of the universe. But what exactly is dark matter? How do we know it exists, and could it hold the key to unlocking new physics? Let's explore one of the greatest mysteries in science. How do we know dark matter exists? If we can't see or detect dark matter directly, how can we be sure it's real? The answer lies in gravity and motion. Scientists have observed multiple pieces of indirect evidence that suggest something invisible is influencing the structure of the universe. 1. The speed of rotating galaxies. One of the first major clues came from the work of astronomer Vera Rubin in the 1970s. She studied how stars orbit galaxies and found something surprising. According to Newtonian physics, stars near the center of a galaxy should move faster than stars at the edges, similar to how planets in our solar system orbit the sun at different speeds. Mercury moves much faster than Neptune. However, Rubin discovered that stars on the outer edges of galaxies were moving just as fast as those near the center, something that shouldn't be possible if only visible matter was present. The only explanation? There had to be extra mass, an invisible form of matter, generating additional gravity and holding galaxies together. This hidden mass, which didn't emit any light, became known as dark matter. 2. Galaxy clusters and missing mass. Decades before Vera Rubin's discovery, Swiss astronomer Fritz Zwicky observed something strange about galaxy clusters, huge groups of galaxies bound together by gravity. In the Coma cluster, he found that galaxies were moving so fast that they should have flown apart based on the visible matter present. Yet they remained bound together, suggesting that there was a huge amount of unseen mass creating extra gravitational pull. Zwicky called this unseen mass Dunkel Materie, dark matter, and his calculations showed that galaxies contained at least 10 times more mass than what was visible. 3. Gravitational lensing, seeing dark matter's effects. One of the strongest pieces of evidence for dark matter comes from gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. When light from a distant galaxy passes near a massive object, such as a galaxy cluster, the object's gravity bends and distorts the light. Just like a magnifying glass bending light, scientists have observed gravitational lensing effects that cannot be explained by visible matter alone. This suggests that huge amounts of unseen mass, dark matter, are bending light and shaping cosmic structures. 4. The cosmic microwave background, CMB radiation. The CMB radiation is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. It provides a blueprint of the universe's structure. Precise measurements of the CMB from missions like WMAP and Planck show patterns that suggest the universe is made of 5% normal matter, 27% dark matter, and 68% dark energy. Without dark matter, the universe's structure wouldn't match the way we see it today. All of these observations provide overwhelming evidence that dark matter exists, even though we still don't know what it is made of. What is dark matter made of? Even though we can detect dark matter's gravitational effects, scientists still don't know its exact nature. There are several leading theories about what dark matter could be. 1. WIMPs, weakly interacting massive particles. One of the most popular theories suggests that dark matter consists of exotic particles called WIMPs. WIMPs would be much heavier than protons but interact very weakly with normal matter, only through gravity and possibly the weak nuclear force. Despite extensive searches using underground detectors and particle accelerators, WIMPs have never been found. 2. Axions. Axions are hypothetical, lightweight particles that could be another form of dark matter. They were originally proposed to solve a problem in quantum physics related to the strong nuclear force. Some experiments, like ADMX, Axion Dark Matter Experiment, are searching for these particles, but so far, none have been detected. 3. Primordial black holes. Some scientists suggest that dark matter could actually be made of tiny black holes that formed in the early universe. These primordial black holes would be too small to detect directly, but their combined gravitational influence could explain dark matter's effects. However, recent studies suggest that black holes alone cannot account for all dark matter. 4. New unknown particles. Some physicists believe that dark matter could be something completely unknown, possibly requiring an entirely new branch of physics to understand. This means dark matter could be the key to unlocking new laws of nature. Why is dark matter so important? Dark matter isn't just an interesting theoretical concept. It's one of the most important forces shaping the universe. Holds galaxies together. Without dark matter, galaxies wouldn't have enough gravity to stay bound together. Shapes the cosmic web. Dark matter acts as a scaffolding for the universe, forming massive structures where galaxies and galaxy clusters grow. Influences the evolution of the universe. Dark matter affects the way the universe expands and could hold the key to understanding cosmic evolution. Might unlock new physics. If we can identify what dark matter is made of, it could lead to groundbreaking discoveries in fundamental physics. Could we ever detect or use dark matter? Scientists are working on several ways to directly detect dark matter. Underground detectors. Huge experiments like Xenon NT and Lux Zeppelin are searching for dark matter particles interacting with normal matter. Particle colliders. The Large Hadron Collider, LHC, is smashing particles together to see if dark matter particles are produced. Space observatories. Telescopes, like the Fermi Gamma Ray Space Telescope, are scanning space for potential signals from dark matter. If we ever understand and harness dark matter, it could lead to new energy sources, advanced propulsion systems, or even technologies beyond our imagination. Conclusion: the ultimate cosmic mystery. Dark matter remains one of the greatest unsolved mysteries in physics. It's everywhere, yet we can't see it. It shapes galaxies, yet we don't know what it is. Will the next big discovery finally unlock the secrets of dark matter? Could it lead to revolutionary new physics? The search continues, and the universe still holds many secrets. What do you think dark matter is? Could it be the key to new discoveries? Let's discuss.